All right, so we talked about attacks and the different types of attacks. Now we're going to see what we're doing in terms of attacking what we actually do and what we do on the network itself. So this module is going to be explaining about IP service vulnerabilities and explaining how network application vulnerabilities can enable those attacks to happen. So some different IP services that we have running. Hosts will broadcast their ARP requests to other networks or to other hosts, on the same network segment. And that is what they use in order to determine the MAC address. And then that way they can get that logged within the switch or the routing device that's processing the traffic on the network. The host itself will take the matching IP address to an ARP request, and that ARP reply is end up referred to as a gratuitous ARP. So if we see the little demonstration over there on the right-hand side, the host 1.5 is going to say I must send out an ARP request to learn the MAC address of the host with the IP address of 1.7. It sends it out. You see this isn't me. For the two hosts, it's not. And then the one that does respond will say it's me, and here's back my MAC address. So standard ARP cache, the difference here is that a threat actor can end up poisoning this ARP cache on the device by simply responding and saying, oh, that MAC address, or I'm this IP address, here's my MAC address. And so the goal is to intercept that traffic and then get it redirected to them. To do that, you have to end up doing what's called ARP cache poisoning. So it's used to launch various man-in-the-middle attacks. And you guys will be going through some man-in-the-middle attacks. The ARP cache poisoning process is very similar to the standard ARP, standard ARP request. So you're sending the request, you get a reply back. However, we've ended up spoofing replies. So if we look over here, you'll notice that ARP reply here 10.1 has that MAC address. 10.10 also has that MAC address. And so when you do that, it's going to cause that threat actor to get access to the traffic because you're going to end up routing it to them without thinking about it. If you look up here at the ARP cache on R1, note that it thinks, as well as the ARP cache on PCA, they all think in order to get to that traffic, they have to end up sending all of that over to the threat actor. So there's many tools to create this. There's ones called DNS Sniff. Cane Enable is popular on Windows, as well as EtherCap, Yersinia, and others. So DNS attacks, this is going to be when you're requesting for DNS information on your network. Typically, a DNS resolver will go to some public server. So this could be your ISP. It could be Google DNS is a very popular one. Google DNS being 8.8.8.8. You also have 8.8.4.4. And so a lot of times clients will be configured to get this outside of their administrative domain. And because those open DNS resolvers are vulnerable to multiple malicious activities, for example, you could do DNS cache poisoning. This is where the threat actors will send spoofed, falsified record resources, information within the DNS resolver to redirect users to legitimate sites to malicious sites. You have DNS amplification and reflection attacks. This is basically going to be sending DNS messages to open resolvers using the IP address of the target host. You're also going to have resource utilization attacks. This gets into your denial of service attack on a DNS, where you're trying to consume all the available resources and therefore negatively affecting the operations of the DNS server itself. There are what is known as stealth attacks, and the idea here is to hide their identity. The techniques that they use is called like fastflex. This one is where they will use a technique to hide their phishing and malware delivery. Typically, this is continuously changed within minutes. What they're doing is just randomly keeping everything moving in the network. You can have a double IP flux. This is where they're going to be rapidly changing the host name to IP address mappings back and forth. And it can also change the authoritative name server. It increases the difficulty of identifying the source attack. Some domain generation algorithms. This one's a little different. I haven't really used this one. In malware, it's randomly used to generate domain names that can be used as a rendezvous point for a command and control server. So the idea is to get it to redirect and randomly generate names as well. So you also have DNS shadowing attacks. These are used to gather domain account credentials in order to create subdomains. And the idea is that you can get access to their DNS, whoever's running their DNS system, gather those credentials so that you can go in and build a bunch of subdomains. And then you can make people think they're going to a legitimate subdomain that's being redirected and pointed out to malicious servers. Because they think it's part of the original parent domain, a subject or a victim isn't any wiser. All right, we also have what's called DNS tunneling, and then this is necessary for a cybersecurity analyst to be able to detect this when an attacker is using tunneling to steal data and prevent and contain the attack. One way to accomplish this is that the analyst must implement a solution that can block the outbound communications from the infected hosts. Actors who use DNS tunneling place non-DNS traffic within DNS traffic. The idea is that it often circumvents security solutions. So if you have an IDS or IPS that is looking for DNS information, but they're seeing a bunch of other traffic in along with that, it more than likely will prevent the scripts from actually picking up on the signatures of the type of attack that you're pulling off. So the threat actor is using DNS tunneling, where they're going to send different types of DNS records, such as text, mail records, service records, null records, A records, and CNAME records, where they're all altered. So for example, you could take a text record and you can store commands in it that are sent to infected host bots as DNS replies. And a lot of times, you know, the text records and such are used with random string information. And so it's normal to see random string type things go through there. And therefore you would have to actually filter based on commands. So in order to stop DNS tunneling, you must filter and inspect the DNS traffic. For DHCP, this is where we're trying to offer dynamically provided IP address information. In this figure, you can see how DHCP works. So in a normal DHCP operation, you start with a client that says they would like an address. There's an offer come from the server. It's done via unicast, and then it gets sent all the information over to the client. The client sends a request, broadcast back, and says they accept the offer. And then the DHCP acknowledge comes back from the server and says you've been acknowledged, and it marks it in the database. So standard technique. However, with attacking, you can do DHCP spoofing, in which a rogue DHCP server is connected to the network and then provides false IP configuration information to the legitimate clients. It can be misleading information, such as the wrong default gateway, therefore routing everything to a threat actor and causing a man-in-the-middle attack. You could also have the wrong DNS server, in which the threat actor will actually point back to a malicious website or their own DNS server to serve things up. And you could serve up the wrong IP address. And if you serve up the wrong IP address and default gateway, etc., that ends up creating a denial of service attack on that client because they won't be able to communicate on the network. So you will have a couple labs in this particular module. You'll go through and explore some DNS traffic so that you fully understand how that works. For enterprise services, you have HTTP and HTTPS. This is going to be able to investigate the web-based attacks. And so therefore, you must have a good understanding of how web-based attacks work. So common stages of a typical web attack: the victim unknowingly visits a website that's been compromised by malware. That compromised web page redirects the user to a site containing malicious code. The user will then visit that site with malicious code and their computer becomes infected. Then they identify a vulnerable software package running on the victim's machine and then use an exploit kit to download the malicious code to exploit that. After that point, the victim's computer has been compromised and connects to the malware server, downloading the payload, and that final malware package is then ran on the victim's computer. So server connection logs will often reveal the type of attack or the scan that's going on. Remember your different connection codes from HTML or HTTP. You have informational, which are the 100 codes, successfuls are the 200s, redirections are 300 codes, and then client errors are 400 codes. Server-side errors are going to be 500, the 500 block. So to defend web-based attacks, always update your operating system and browsers with current patches and updates. You can try to use a web proxy in order to block malicious websites. It's best to use practices from OWASP when developing web applications. OWASP is a very known security project that gives you the top 10 things that are going to be causing problems for web applications. For example, opening yourself up to SQL injection, etc. So you should definitely go out and play with OWASP. As a matter of fact, I believe we have some of that inside our labs. And then it's important to educate the end users to show them how to avoid being attacked through web-based attacks. So malicious iframes. An iframe is an HTML element that it allows a browser to load one web page from another. In an iframe attack, the threat actor will insert advertisements from other sources into the page. Therefore, the threat actors can compromise a web server, modify the web pages, and add HTML for the malicious iframe. As soon as that iframe is running in the page, it can be used to deliver the malicious exploit, such as spam advertising, exploit kits, and other malware. There again, to prevent or reduce these type of malicious iframes, you can use a web proxy. Web developers try not to use web iframes anymore. Use a service such as Cisco Umbrella to prevent users from navigating to malicious websites. And you can also ensure end users understand what an iframe is. And so you'll see this on a lot of web pages, particularly if you're downloading quote unquote free games from the internet. You'll see a page just littered with different iframes. Typically all malicious. You have HTTP 302 cushioning. What this is you use the 302 found HTTP response status code in order to redirect a user to a web browser to another location. And therefore, the browser believes the new location is the URL that's provided in the header back from the web server. And the browser is invited to request this new URL. The redirection function can be used multiple times until the browser finally lands on a page that contains the exploit. So you may have seen this before as you're browsing through the internet, and then suddenly the web page just keeps refreshing, and you end up landing on a malicious site. In order to prevent or reduce that, there again, using a web proxy is great. You can block malicious sites. You can use a service such as Cisco Umbrella in order to prevent users from navigating to malicious websites. And you can also ensure the end user knows how the browser is being redirected through multiple things. So if you start seeing a bunch of redirects, close the browser. For domain shadowing, we talked a little bit about this on a shadowing attack. Again, they have to compromise the domain. They're going to create subdomains in order to use during the attack of the hijacked domain registration login. From there, they will use those subdomains, and the attackers will use them to create malicious domains, and therefore they can make more for the parent domain. So if you get a subdomain that's found as malicious, they just simply generate another one because they have your domain credentials. So it's very important to make sure that you secure all domain owner accounts, that you use a web proxy to block malicious websites. There again, Cisco Umbrella, and then make sure domain users validate their registration accounts and look for any subdomains that have not been authorized. Using things like two-factor authentication on domain accounts is strongly encouraged. Okay, so for email, here, level of use as the email rises, security has become a greater priority. For example, users today can access email on just about any devices out there, and therefore you have multiple ways to attack different devices for the end user. You have attachment-based attacks. We've seen these since the very early days, where threat actors will just embed malicious content in a business file, such as an email from the IT department. You will also see things like email spoofing, in which we create email messages with a forged sender address that is meant to fool the recipient into providing money or sensitive information like usernames, passwords, etc. You'll see spam emails, which are unsolicited emails containing advertisements or malicious files. And then you can also see things go through an open mail relay server. It's an SMTP server that allows anybody on the internet to send a mail. And so typically you want to see things only come from authenticated servers. With web exposed databases, most web applications today commonly connect to a relational database in order to access that information. As relational databases often contain sensitive information, databases are a frequent target for attacks. And so this leads us into code injection, in which we can send commands that are executed through the web application, and it has the same permissions as the web application. So when you're designing web applications, etc., you want to make sure that the permission set for these type of things only have the permissions they need. And therefore, this type of attack is usually based on insufficient validation of input. So if you're not sanitizing your input coming in from the users, aka search fields or input fields, that's going to lead you to code injection. You could also have SQL injection, which is where a threat actor will breach the relational database, start creating malicious SQL queries, and so that they can pull information out of things that aren't even in the same database as what they're currently pulling from. Whether it's multiple databases or different tables, they can pull all sorts of information that they wouldn't normally have access to. So a successful SQL injection can read sensitive information. They can modify database data, in other words, change passwords. That way they can log in as an administrator or a root, and then execute administrative operations. And in this case, inject commands clear down to the operating system. For client-side scripting, also known as XSS, this is where web pages that are executed on the client side and within their own web browser, and then have injected malicious scripts in them. So these scripts can usually be, Visual Basic, JavaScript is very common, or others to access the computer itself, collect the information, and then deploy an attack and spread more malware. There's two types of XSS or cross-site scripting. You have stored or persistent, or you have reflected, which is non-persistent. In order to reduce or prevent these, you can ensure that a web application developer is aware of cross-site scripting vulnerabilities and how to avoid them. You can use an IPS or intrusion prevention system in order to detect and prevent malicious scripts. You can use a web proxy again, and you can also use things like Cisco Umbrella. So you will go through a lab in which you will attack a SQL database. So you'll look through a PCAP file where you're looking through an attack that's happening on a SQL database. You'll also have a lab in where you're reading server logs, and that way you can become familiar with how to identify these attacks within the log systems. Right now, you're just going to be looking at the log systems directly on a host. Eventually, we will get to where we're working with SIEMs, et cetera, where this information is being sent to. All right, so to summarize everything in this module, any client can send an unsolicited ARP reply, known as a gratuitous ARP. This allows a threat actor to poison the ARP cache of devices on the local network, allowing for a man-in-the-middle attack to redirect traffic. With the DNS protocol, you have resource records that are used to identify a type of DNS response. You can have open resolvers that are vulnerable to multiple malicious activities, including DNS cache poisoning, in which they're falsifying records that are provided from the open resolver, for example, Google and things like that. In DNS amplification and reflection attacks, these are benign nature of the DNS protocol, exploited to cause DOS or distributed DOS attacks. DNS resource utilization attacks, you're basically launching a DOS attack against the DNS server itself. Therefore, it cannot respond to the DNS requests. You can have threat actors use fast flux, in which malicious servers will rapidly change their IP addresses. You can stop DNS tunneling by setting up a filter that will inspect the DNS traffic. We also talked about DHCP spoofing, in which a rogue DHCP server is connected to the network and starts providing false IP configuration information, as well as even causing a DOS attack by falsifying the information entirely, and therefore the network client won't be able to communicate on the network. You can also send compromised web page redirects to a user site and that hosts malicious code, and that's known as a drive-by download. You have cross-site scripting, which is attacks when a browser executes malicious scripts on the client and therefore provides threat actors with access to sensitive information on the local host. And then we talked a little bit about OWASP Top 10 Web Application Security Risks. This is designed to help organizations to help secure their web applications. So it gives you the top 10 tips and tricks to look for when designing web applications. And that will close out this module.